We are in Algebra 2. Today's date is Monday, January 27th, 1/27, 2020. We are solving exponential models. That means our objective is to do what, Jaden?
Use all the properties of logarithms to solve real-world problems.
Yep, real-world problems with our applied mathematics using our undo button, the logarithm. All right, so let's talk about caffeine. Who wants to read? Quiet raised hand. I saw Chewy first.
Caffeine has an average half-life of 6 hours in the human circulatory system. If an average cup of coffee has 100 milligrams of caffeine, then the amount of caffeine in your body can be modeled by the function. Read that.
You don't need to. Where T
Also, I do.
where T is
Where T is 100 of a half.
where T is measured in. Just keep reading. You don't have to read the equation.
Oh, I didn't see that. My bad. Where T is measured in hours and CT is measured in milligrams. How much caffeine will you have in your body after 4 hours?
Yeah, so I've done the hard lifting, right? I said, okay, your equation, your exponential equation that you guys are being able to do, and you should have your laptops all closed, is you do your initial value. Okay, initial value, you have 100 milligrams because you drank some coffee, so laptop closed, please. And that's about average. So if you go to Starbucks, it might be 110. If you get like a double espresso, it might be 200. But on average, if you just drink some black coffee, it's 100 milligrams on average. And I said, okay, a half-life. That means in however much time, if the half-life is 6 hours, in 6 hours, I will have half the amount of caffeine. So that means in 12 hours, I will have, quiet raised hand, how much of the caffeine left in your body? In 12 hours, I'll have half of half, which is, anyone, quiet raised hand, Ellery? A quarter. So in 12 hours, I'll have a quarter. Half of a half of a half. So I set up your equation. I know that my common ratio is a half because I multiply by half and a half and a half. And I always do the time on the bottom, right? T divided by 6. So it's half-life of 6 hours, so T divided by 6. All of this should be review at this point. You know how to create this equation on your own. In fact, if I'm going to be giving you half-life over and over again, your common ratio should be a half and a half and a half. It's not really going to change that much. Only your initial amount, 100, and this times 6 are going to be the numbers that change. So I want to know how much caffeine you're going to have in your body after 4 hours. And since 4 is a measure of time, I'm going to plug in time for T, and all I have to do is plug that into my calculator. So everyone write this down. This is the easiest type of problem. If I just have C of 4 hours, I'm plugging in 4. Everywhere that you see a lowercase t, plug in 4. So now I say, okay, this is going to be equal to 100 times 1/2, all of this to the power of 4 divided by 6. And then this is just something that we do on our calculator. So let's come over here and do that. We have
Why is it green?
we have desmos.com/scientific, and I'm going to type in 100 times 1/2 to the 4th 6. 100 times 1/2, all of that, 100 times 1/2 to the power of, and this is going to be a fraction, 4 divided by 6. And the answer is 62.996. And do I say how much to round to? Let's just round to the nearest whole number. Let's say 63 milligrams. So this is equal to 63 milligrams.
That's all I have to do.
That's all you have to do. You just have to plug it in. If it tells you a time, you plug in that time. And that's a very general rule for all of Khan Academy. If it tells you a time, plug in that time. We plugged it in, we typed that into our calculator, we got 63 milligrams out, which is kind of cool. And this is a real problem. If you drink a cup of coffee, you will know that after 4 hours, you should have 63 milligrams of caffeine in your system. Maybe you have a high tolerance to caffeine, maybe you don't, but regardless, you'll still have 63 milligrams of caffeine unless you had a coffee within the last, 24 hours also. All right, so this is kind of cool. This is what I estimated. I can't sleep if I have 20 milligrams of caffeine in my body. I want to know when I can go to sleep. This is like a real question. Maybe you just drank, I don't know, Mountain Dew, something that had caffeine in it, a Red Bull, I don't know. And you want to know, okay, well, when can I go to sleep? If you know how much caffeine you can have in your system before you can go to sleep, you can actually mathematically calculate that. So for me, it's 20 milligrams. So if I drink coffee that we assume has 100 milligrams of caffeine, so I can still use the same equation, how many hours do I have to wait until I can go to sleep? So I know that my amount of caffeine, remember, C of T is my amount of caffeine. So I'm going to say, okay, I want this C of T on the left-hand side to be 20. When does this equation become 20? So I'm going to come back down here. I'm going to say 20 is now equal to. When does that right-hand side become 20? Well, then I just rewrite all of this right-hand stuff. So it's going to say 20 is equal to 100 times 1/2. All of this to the power of t divided by 6. And I solve. And if you're scared, like, wait, the variable is in the exponent, Mr. Sennell, I'm like, oh, but you have a way of getting that exponent down that we discussed on Friday. So first, let's try to isolate for just this exponent. So I'm going to get rid of this 100. How am I going to do that? Quite raise your hand. What am I going to do to both sides? India, do you still have your card? Yeah, India.
Divide by 100.
Yeah, divide both sides by 100. So divide by 100, divide by 100, and 20 divided by 100. What does that simplify to, India?
1/5.
Yeah, so I have 1/5 is now equal to 1/2, all of that to the power of t over 6. All right, now it's time to use our undo button. How do I undo something that has an exponent? Does anyone remember? And what my base of that should be? Ellery?
So you move the exponent to the side, so you have t over 6 times log 10 of 1/2.
Careful. Choose your base so that it matches with the base.
Times log 1/2.
Log of 1/2, all of that to the 1/2, like that. And then I also have log of 1/2 on the left-hand side too. Log of 1/2 of 1/5. All right, so Ellery did 2 steps, and I want to make sure that everyone can follow. The first step was just taking the log base of 1/2. So if I was being a little bit more careful and doing 1 step at a time, go away, phone battery. What I could have said here, oops, let's do this. I could have put this t over 6 all up here to the power of 6 and then move this parenthesis like this. This is a little bit more careful of a way of writing this. All we did, this is the same line, but we added log base 2, or log base 1/2, to the 1/5. Log base 1/2 to the 1/2 t to the power of 6. All we did was take the log of both sides. We're allowed to do that. And then from there, Ellery's using the rule that says, hey, if I have an exponent, that exponent can come down in front of the logarithm. So that would be my next step. If you already showed that step, then you don't have to copy this down. But my next formal step here would be saying, yeah, this is going to be log base 1/2 of 1/5 is equal to t over 6. I brought that t over 6 down in front of the log base 1/2 of 1/2. All right, and then the next question is, what is log base 1/2 of 1/2? And you should know this from Friday as well. Who has this with the quiet raised hand? Anna? 1. These cancel each other out. Log base 1/2 of 1/2 is 1, and 1 times t over 6 is t over 6. Essentially what that means is I can cross it off. So let's go ahead and just cross it off for now. That's gone, and now I have the equation t over 6 is equal to all this logarithm. What do I do to finally solve for t? I do what to both sides of the equation? Right now I have t divided by 6, the inverse operation of divide by 6, Beverly. Multiply by 6. So I multiply by 6, multiply by 6, and my answer, in red, I can do it down below, is 6 log base 1/2 of 1/5 is equal to t. And that doesn't really help us, because if you gave that to a computer, they'd be like, oh yeah, I got it. But generally speaking, we don't know how to do logs of bases that are not 10 or e. So we need to use the change of base formula. So that is the answer, but using the change of base formula to actually use the answer, we can say, okay, that's still 6 out front. How do I convert log base 1/2 of 1/5 using the change of base formula? Log of something divided by log of something. Do we remember that one? Go back to your notes if you don't remember. Change of base formula. We did that on Thursday. Change of base formula. I have the same people participating over and over again. I'm going to call on someone that's flipping through their notes hopefully right now. Change of base formula. I think that was 8-4. What is that change of base formula? Who's got it? I'll do the basics. Log of something divided by log of something. Cheyenne? There it is. Thank you, Cheyenne. And there is my answer that I can now actually enter into my calculator. Again, the 1/5 comes on the top, the 1/2 comes on the bottom because bottom for base. And now I have to type all this in. So I come over here. Let's zoom in here. I have 6 log of 1/5 all of this divided by log of 1/2. And the answer is 13.93. 13.93, and our units are hours. Question, Jaden. Oh, restroom, yeah. Can you wait until the end of the lesson? You're almost to my favorite problem. Which is interesting, right? So I am kind of a weakling when it comes to caffeine. I cannot sleep if I have even 20 milligrams of caffeine. If you think you can sleep with a coffee in you, then you have more resilience than I do, and this number would be lower. But for me, 13.93 hours if I drink 1 cup of coffee, which means if I want to go to sleep by 8, I need to be only drinking my coffee by 6 in the morning.
So is that like you were up to 11 last night?
Last night I was only up to 1:30. But I don't drink caffeine, so that's why I'm such a weakling. All right. I was not, no. I was working on these notes. I was looking up Chernobyl again. All right, we're on example 2, our final example. This one is fun and sad at the same time.
Does that depend on your weight as well? How much you can have?
There's so many factors. This is a very oversimplified way. The average half-life is 6 hours. Like if you have a very, very good, like I can metabolize anything and I'm super, super skinny, the half-life is going to be like 4 hours or something. If I maybe don't metabolize as well, it takes me a long time to digest, then maybe your half-life is going to be 8 hours. It depends on a ton of different factors. Not only your weight, but your metabolism, like the weather, a ton of things. Okay, so on April 25th, oh wait, who wants to read this? Someone that hasn't participated yet, hopefully. Oh yeah, Sam. She's no. Okay, Illyria.
The Chernobyl disaster happened on April 25th, 1986 in Soviet Ukraine. One of the many radionuclides that spread from Chernobyl was cesium-137, which has a half-life of 30.2 years. Cesium-137 tends to accumulate in soft tissue like many of our vital organs. We can model an initial amount of cesium-137 I with the equation CT equals I times 1/2 T over 30.
Right, yeah. So it's crazy to think about, right? Really put this in perspective. A half-life of 30.2 years. That means even after, I don't know, what is the average lifespan of a human? Is it like 60 years old? In half of a generation, there's still going to be half of that radioactive material left over. Which means even after your full, like 60 years, there's still going to be a quarter of that radioactive cesium-137.
So when is it all gone?
That's the question, right? When is it all going to be gone? So we can actually treat this, I'm going to try to see when is only 5% of it left. Because you can't have none. You're always going to have some. That's the unfortunate side effect of having something that's exponential. An exponential equation will never go away. It will get closer and closer to 0, but it's never actually gone. So I'm only going to go with 5%. Is there a question?
I just realized because what you said, because it's a half, it's just going to keep getting smaller, and it'll be like a 0.000000, but there's still something left.
Right, exactly. In a million years, it might be 0.000 forever and then 1, but there's still something, right? And Elder, I saw your hand.
No, I wasn't raising.
Okay. All right. So we all understand that cesium-137. We are soft people. We are not made out of rocks. Therefore, cesium-137 is in us, and it will cause cancer. All right. So this is a hard question because there's no amount. I don't know how much cesium-137. That's kind of the beautiful part about this mathematics. I don't need to know, but I will be able to tell you when there's not going to be any left. I don't know what the initial amount is. It's still I. It's an unknown variable. But I want 5% left over. And this is going to be a little bit of the harder math that we're doing. All right, so how do we set this problem up? I want remember, C of t represents how much you have now, and I represents how much you had to start with. So if I want to do a percent, I don't know why that went away. Here is your kind of cheat sheet. If you want your percent is equal how much you have now versus how much you started with. AKA, this is C of t divided by I. How much you have now is your C of t. How much you started with, your initial value was I, which means if I divide both sides of this equation right now, divide both sides of this equation by I, then this side will be C of t divided by I. This side will be the percent I'm looking for. I can just move this I to this side and then treat that as 1/20 or 5%. 5% and 1/20, we're all okay. Those are the same number. This is just as a percent. This is as a fraction, a rational. So this is the work that I'm doing. I am dividing both sides by capital I, dividing both sides by capital I. Now that I have C of t divided by I, C of t divided by I, that is the percent, which is 1/20. So my new equation reads like this. 1/20 is equal to 1/2 of all this to the power of t divided by 30.2. Very, very similar fraction in the second part of the equation. Your second equation is going to have 1/100th instead of 1/20th. That's the only change. Now you're going to use your log rules to try solving it. It's going to be the exact same procedure for all of these problems, even on Khan Academy. You first isolate for your base and your exponent, which has already been done in this case because we don't have any initial value. Then we're going to take the logarithm of both sides, and then we're finally going to isolate for your variable, for your unknown. So I'm going to do log base what of both sides? I need a quiet raised hand. Log base what? I know Beverly knows. I know Ellery knows. Go ahead and do it. Those of you that know how to do it, just go ahead of us. It's fine. Log base what? We'll give it to you, Aurelio.
What?
So check out this last one, right? So we wanted to get rid of this 1/2. So we took the log of base 1/2. So if we want to get rid of this 1/2, we're going to take the log base of
That one.
1/2. All right. So let's follow Aurelio's instructions. Take log base 1/2 of both sides. This is what it looks like now. We now have log base 1/2 of whatever was on the left-hand side. Left-hand side was 1/20th, so we say log base 1/2 of 1/20th. On the right-hand side, I now have log base 1/2 of the right-hand side, which is 1/2 to the power of t over 30.2. 1/2 t divided by 30.2. All right, so that was Aurelio's step. After Aurelio takes the log base of 1/2 of one each side, this now has permission. The exponent has permission to come down in front of the logarithm. So I'm going to kind of skip that step because we're kind of low on room. But this t divided by 30.2 is going to come down in front, and then I'm going to be left with log 1/2 of 1/2. What is log base 1/2 of 1/2? Oscar.
It's talking about you, Oscar.
Log base 1/2 of 1/2 is?
It's 1/2.
Not quite. Anything to itself is just 1. So if I come back over here, check this one out. Log base 1/2 of 1/2, that cancels out to 1, and then 1 times t over 6, we just left that as t divided by 6. So once again, Oscar, what is, for our problem, log of 1/2, log base 1/2 of 1/2?
It's 1/2. No, I'm joking. It's 1.
You almost got me. All right. It's 1, which means that cancels out. And our new equation looks like this. And I'm going to do a change of base formula. I'm going to do 3 steps at the same time. Hopefully we're all able to follow me. The left-hand side doesn't need to change, but I'm going to change it with a change of base formula. This is going to be log of something divided by log of something. Does anyone remember the change of base formula just for this left-hand side? I see people that do know it, but some people do not know it. Caroline. Do the inside on the top, base on the bottom. So log of what? Divided by log of 1/2, yeah. There it is. Thank you. Yeah, so Caroline has done the change of base formula. And on the right-hand side, what do I have left over? This t divided by 30.2. T divided by 30.2 that I brought down from the power. All I have to do now is multiply both sides by what? Quiet raised hand. Easy way to get your participation point in. Sam, you haven't participated yet. What do I do to both sides? What is the inverse operation of divide by 30.2?
Multiply
By,
30.
there it is, 30.2 on that side. That's going to cancel out there. Ooh, that's a bad canceling out. There it is. And multiply by 30.2. And we have our answer. T, by itself, isolated, is all of this stuff. So let me go ahead and calculate what that is. So I had 30.2 times log of 1/20th all of that divided by log of 1/2.
What is it called?
And we have our answer, 130.5.
130.5 is the answer.
0.5 years.
Is the answer.
That is our answer.
What's the answer?
Now I want you to think about this in terms of the proper perspective. What was the date of Chernobyl? Someone shout it out.
1986.
April 25th, 1986.
1986. So, what is 130 years after 1986? What is 100 years after 1986?
2086.
2086. And then you have to add another 30 on top of that. Not until 2100, even further than that. Even in 2100, we're still going to have over 5% radioactive cesium-137. We're not even there yet. I guess another question that I could have asked instead of doing this one is, how much or what percent radioactivity do we have today? You can answer that question now that you have logarithms.
Can we go to the bathroom now?
We're almost done. I want everyone to solve this last question, and then after that, you can go to the bathroom
Dude, I
or
don't
work
even
on
know
Khan
how to,
Academy. I'll come work with people that need help.
Yeah, like, yeah.
All right, so this next problem is very, very similar. The only thing that changes is this 1/20th turns into a 1/100th. So my new equation is 1 over 100 is equal to 1/2 of t divided by 30.2. Again, I need to now solve for this thing, so I guess I could move this a little bit over to the right so I have room to take the log of both sides. So I'm going to now take the log base 1/2 because this is a base of 1/2 of each side. So when I do that, I have log base 1/2 of 1/2 to the power of t divided by 30 over 2, and this is also log base 1/2 of 100 on the left-hand side. Notice that this power again is going to come down in front of the logarithm, and this log base 1/2 of 1/2 right here just kind of cancels each other out. And what I have left on the right-hand side is just this t divided by 30.2. On the left-hand side, I have all this stuff. It's a change of base formula yet again, which means I'm going to have log of the inside on the top, log of the base on the bottom. So I'm going to have log of 1 over 100 on the top, and log of 1/2 on the bottom. And the final step is to multiply both sides by 30.2 to get rid of the 30.2 right there, and 30.2. And if I enter this into my calculator, I will get the right answer if I'm running to the right number of decimal places. Let's go here to my calculator, pull that back up. And it's 30.2 log of 1 over 100. 30.2, and I can zoom in here, times log of 1 over 100. All that's going to be divided by log of 1 over 2. Oh my gosh, 200.64 years. That's 200.6 years until only 1% of the cesium-137 is left over. And that is our final answer.